So in today's video, we're going to take a look at subtracting mixed numbers with unlike denominators. And once again, we're going to be using an equivalent fraction strategy to produce an equivalent difference of mixed numbers with like denominators. So likewise with everything we've done with adding and subtracting fractions, that key component is setting up with a pair of mixed numbers with like denominators so that we're able to actually engage the operation. So let's go ahead and take a look because there's a couple of different examples I want to get through with this particular video. And I want to kind of zoom in here and we will explore just a few options in terms of what you might see. So likewise, I'm going to kind of come up here spatially and set myself up for my step 1, 2, and 3, which have been very consistent throughout the addition and subtraction of fractions process. So the first step is, let me write my problem down. So I'll say I have 3 1/2, and I'm going to subtract 1 1/4. So the first step in order to do this is I'm going to, as we've reviewed throughout, is step 1 is just to set it up. And then step 2 is the equivalent fraction portion of the process. And so in the equivalent fraction portion, which has, I know it's very repetitive in terms of each video really emphasizes this, but as we've talked, this is really that crescendo of the unit in terms of understanding how to work the process and conceptually understanding that with fractions we must be like denominators so that we're comparing apples to apples rather than apples to oranges. So we'll come down and we're going to write our fractions down, and we'll say 1/2 and 1/4. I'll make this one multiplier, as I've said. The 1/2 and 1/4, these are what everything is multiplied by. So I write above it the 1. That means 1 times 1/2 equals 1/2 because 1 times anything equals itself. And then my next multiplier is I'll say 2. And so I go numerator times 2, which is 2. Denominator times 2 is 4. And really right off the bat, as you can see, I hit a common denominator where it's 2/4 and 1/4. So I always walk through that process just to kind of show that understanding. Now I want to go up and enter step 3, which is to solve the problem. So when I hit step 3, I'm looking to solve. So as we did with adding mixed numbers, we want to, first thing is bring our whole number down. And I always kind of set a frame up like so, because I know I'm going to have a whole number and a fraction. I look at 1/2, and it went to 2/4. My 1/4, its multiplier was actually 1, so it stayed the same and just comes down as is. I think I use those numbers intentionally because I want you to be okay with the fact that there are times when one of the two fractions may not change, and that's completely okay. Again, the goal is that we're hitting where both of those denominators are the same. So at times it may not require you to make adjustments to one of the fractions, and that is completely okay. Again, the goal is to find like denominators using that equivalent fraction strategy, which we have done successfully. Now we look at it and we do it just like we've done before with adding, except we're just operationally doing subtraction. So first thing I'm going to do is look at my whole numbers, and I'm going to say 3 minus 1 is going to give me 2. I know my denominator stays the same, and then 2 minus 1 equals 1. So my answer would be 2 1/4. Now there's another scenario that could play out, and I just want to change some things around real quick. And we're going to take this away, and I'm going to I want to trade the fractions. I want to change the problem in a way that it looks like this. What if I had 3 1/4 minus 1 1/2? So that was the original problem. Then I came down and did step 2 and set it up. And then I came up and said, okay, as I go to solve the problem, I say this is 3 1/4 minus 1 2/4. Now, a common mistake is going to be that students are going to go, okay, 3 minus 1 is 2, and then 2 minus 1 is 2/4, and they may go ahead and simplify that. The problem with that is it's not saying 2 minus 1, it's saying 1 minus 2, so that's incorrect. And we want to make sure that our number sense stays intact of what we can and cannot do. In this situation, we cannot take 2 away from 1, and now it's time to look at a few options in terms of regrouping. So I want to show you 2 techniques when it comes to regrouping. The first technique requires you to have an understanding that this 3 is actually built of 3 4/4. If a whole is 4 parts, we have 3 whole parts, or 3 whole groups of 4 parts. So that's what that 3 would look like. And then you have a 1/4. So the first way we're going to look at doing this is that we're going to take 1. So right now, here's how it's grouped. Right now it's grouped like this. We've got the wholes that are together, and then this is our fraction. Well, what I'm suggesting we do is we reshuffle the deck. This we're going to put together, and then we'll put these together. And what that turns into would be 2 wholes plus 5/4, or 2 5/4. So I took one of the 4/4 that was in the 3, I took one of the wholes, and I just brought it over. Now, you don't have to write all that out. That's kind of what's going on in my head. What you can do, though, is make it as simple as this. I know that the denominator represents the number of parts in each whole. I can add the denominator to the numerator. So 4 plus 1 is 5, and leave the denominator, and then subtract 1 from the whole number. And that becomes 2 5/4. And then the second number we're simply going to bring down. Now I'm in a position where I can subtract because I look at the numerators and 5 is larger than 2. And so I'm in a position where now I can go, okay, let's deal with the whole numbers. And we'll say 2 minus 1 is 1. And then 5 minus 2 is 3. And then my denominator stays the same. Final answer, 1 3/4. Now I want to show you one other way to go about it if the regrouping is a bit confusing for you. And just another way to kind of tackle this problem. So I get here and my number sense quickly tells me, I can't do this. I can't take 2 away from 1. Well, we're in mixed numbers, and another option is to convert both numbers to improper fractions. To convert an improper fraction, let's say IF, to a mixed number, what we're going to do is we're going to multiply the denominator times the whole number, and then add the numerator. So for example, I'm going to multiply 4 times 3, which is 12, plus 1 is 13, and then that would give me 13/4. The denominator in this scenario does not change. I do the same process with the second number. I'm going to take 4 times 1, which is 4, plus 2, which is 6, and this becomes 6/4. Now I subtract the 2 improper fractions, and then I would take 13 minus 6, which is 7/4. Now I would convert the improper fraction to a mixed number. So how many groups of 4 can come out of 7/4? So I would take 4/4 minus the 4/4, which gives me 1. And then my answer is 1, and then what's left over is 3/4, which was the same answer. So either of those strategies are useful in terms of solving, but I think that when that situation of when you need to regroup, we want to be careful not to let this happen, where we just see this and go, okay, that's 2 2/4, or simplifying that to 2 1/2. Because the odds are that multiple choice situation, that's going to be a distracting answer. That's going to make you feel like you've got it correct. But number sense should tell you there that you just can't do that because, again, kind of go to benchmark fractions there is if we estimate 3 1/4 to about 3, and you're taking 1 1/2 away from it, your answer can't be 2 1/2. So that number sense, I should be somewhere in the ballpark of 1 1/2, which, if you look here, 3 1/4, the correct answer is in that ballpark. Again, with our estimations, they're not always accurate, but they're in the ballpark, and it's definitely not 2 1/2. So again, think about your number sense in terms of how you estimate. But that's a look at subtracting mixed numbers with unlike denominators using an equivalent fraction strategy. My number one takeaway, or your number one takeaway, needs to be that when you subtract, just to stop and make sure that your first number is greater than your second number. Otherwise, you need to move into one of the two strategies, whether you regroup or transition to those mixed numbers to improper fractions. Hope this is helpful. Thanks for listening. Talk to you soon.